Our approach, and the preferred approach, is to take a proactive view on the situation, where we look at the design of the plant, we look at the history of any flexible operation related issues that may already have started to emerge, and we also combine that with our experience of doing these types of assessments on many other plants. And putting all of that together, we determine what the highest risk components are. Some of the typical examples of problems that we see are issues like thermal shock from undrained condensate, which moves through superheaters and reheaters during the startup process to cause thermal downshocks. Other issues that we frequently see are problems with the temperature control on HRSG plants during startup. And on some of the coal-fired units, we often see issues with thick-sectioned components where we have large through-wall temperature differentials which develop during transient conditions.
Well, first and foremost, the main aim of the fitness for service is to underwrite safe operation so that no one is at risk on site from any component failing. Secondary aims are to maximise flexibility for the plant by understanding it, so either limiting any exclusion zones, but also allowing them to operate up to a planned window when they are doing other things on site. So a fitness for service assessment ideally is a multidisciplined approach. The more data you have from different sources, the more comprehensive and the more confidence you'll have in the results. So at the minimum level, you will have the calculations of how big a defect can we live with and how long can we live with it for. But at a greater level, if you've got good non-destructive examination, non-destructive testing results, you have confidence in the actual size and there's less uncertainty there. You also potentially have multiple points from previous inspections, which will give you more confidence in the predicted growth rates. And in the best circumstances, it's been possible to take a sample of the actual defects or the damage and examine those.
Uniper also offers an advanced condition monitoring service where we take the instrumentation data from the plant and in real time, and that is trended and compared to so-called normal historic operation. This means that any deviations from normal operation are identified as soon as they take place, and if that deviation reaches a certain threshold, then an auto alert is generated and sent to the plant operator. That then allows proactive maintenance or other measures to be taken before that deviation from normal has a chance to escalate into either plant damage or loss of availability, capacity, or unit flexibility.